For 4.5 billion years, it has been there. Every civilization that ever looked up saw the same face, cratered, scarred, luminous. The moon. Our closest celestial neighbor. Our timekeeper before clocks existed. Our calendar before calendars were invented. Ancient Babylonians tracked its phases to plant crops. Polynesian navigators followed its light across open ocean. The Islamic calendar still marks time by its crescent. But in the 21st century, something extraordinary is happening. For the first time in human history, we're not just looking at the moon, we're going back, and this time, we're staying. NASA's Artemis program isn't Apollo Redux. It's not about planting flags and leaving footprints. Artemis is about building a permanent human presence on the moon, a lunar gateway station in orbit, a base camp near the South Pole, and eventually, a civilization. Artemis 2 will carry astronauts around the moon. Artemis 3 will land the first woman and the first person of color on the lunar surface. And by the end of this decade, crews will be living and working on the moon for weeks at a time. But there's a problem no one expected, a problem that sounds almost philosophical. What time is it on the moon? On Earth, we solved this centuries ago. Greenwich Mean Time, Coordinated Universal Time, time zones. But the moon doesn't have a time zone. It doesn't have a clock. And here's the strange part. If you put a clock on the moon, it would run differently than a clock on Earth. In 1915, Albert Einstein published his general theory of relativity. Among its many predictions was this: gravity affects time. The stronger the gravity, the slower time passes. The weaker the gravity, the faster. Earth's gravity is 6 times stronger than the moon's. That means a clock on the lunar surface runs faster than an identical clock on Earth. Not by much, not by a noticeable amount, but by exactly 56.02 microseconds per day. 56 microseconds, less than the blink of an eye. But over weeks, months, years, it adds up. Since the year 2000, the moon has drifted over half a second ahead of Earth. And for precision navigation, satellite communication, and scientific instruments, half a second is an eternity. In 2024, the White House directed NASA to develop a new time standard for the moon. They called it Coordinated Lunar Time, LTC. Coordinated Lunar Time is to the moon what UTC is to Earth. A unified reference that every lunar mission, every rover, every habitat, and every astronaut can synchronize to. And right now, even before the first atomic clock reaches the lunar surface, you can see it ticking. MoonTimeNow.com tracks coordinated lunar time in real time, computing the relativistic drift from Einstein's equations, microsecond by microsecond. Since the J2000 epoch, January 1, 2000, at noon UTC, the moon has accumulated over 536,000 microseconds of drift. That's more than half a second, and every single day it gains another 56.02 microseconds. But Moon Time Now isn't just a clock, it's a complete lunar observatory, powered by the same astronomical algorithms used by professional observatories, running entirely in your browser. The moon you see on Moon Time Now isn't a photograph, it's a real-time 3-dimensional rendering built from NASA's Lunar Reconnaissance Orbiter data. Every crater, every mare, every ray system, mapped onto a sphere and illuminated by the actual position of the sun. And here's what makes it extraordinary. The moon looks different depending on where you stand. In New York, a waning crescent is lit on the left. In Sydney, it's lit on the right. At the equator, it appears tilted 90 degrees. Moon Time Now computes the exact parallactic angle, the rotation of the moon's north pole relative to your horizon, for any location on Earth. When the moon is low on the horizon, its light passes through more of Earth's atmosphere. Blue wavelengths scatter away, red wavelengths survive. The site models this using Beer-Lambert law, the same physics that makes sunsets red, computing the exact color shift from the real atmospheric path length. 5,192,549 cities. That's how many locations Moontima now covers, every populated place on Earth in the GeoNames database. Each one gets its own page with live moon phase, altitude, azimuth, rise and set times, weather conditions, and a sky visualization showing exactly what the moon looks like from that spot, right now. And it speaks your language, 120 languages, from Afrikaans to Zulu, Arabic to Chinese, Hindi to Icelandic. Every weather condition, every phase name, every atmospheric description, translated and served in the visitor's native tongue. The site explains why the moon appears the way it does. At just 6.8 degrees above the horizon, the moon appears golden orange as its light passes through about 8 times the normal thickness of Earth's atmosphere. The same Rayleigh scattering effect that makes sunsets red. That sentence appears in 120 languages, personalized for the observer's exact location. What did the moon look like on the day you were born? Moontime Now can tell you. Enter any date from 1900 to 2100, and the site computes the exact moon phase using Jean Meus's algorithms from astronomical algorithms. 25 periodic correction terms accurate to within 2 minutes of the United States Naval Observatory. You'll see the phase, the illumination percentage, the zodiac sign the moon occupied, and a 3-dimensional rendering of exactly how it looked. And here's a detail that will make you pause. Because of Einstein's relativity, if you had been born on the moon instead of Earth, you would be older. Not by much. For someone born in 1990, the difference is about 7/10 of a second. But it's real. It's physics. And Moontime Now computes it for any date. Your gravitational time drift, accumulated microsecond by microsecond from the moment of your birth. Behind the website is an open API. A single endpoint, /API/LTC, returns everything. Coordinated lunar time with microsecond precision, moon phase and illumination, ecliptic coordinates, right ascension and declination, rise and set times for any observer location, weather conditions at the observer's location, the moon's apparent color, computed from Rayleigh scattering, as an RGB value, a hex code, and a color temperature in Kelvin, the parallactic angle, optical libration, the subsolar selenographic longitude that determines exactly where the terminator falls, upcoming phases, eclipse predictions, all from a single, no authentication GET request. The API is self-documenting. Add ?help to any request, and it returns its own complete schema, every field, every type, every range, every unit. In the coming years, there will be clocks on the moon, real atomic clocks, synchronized to coordinated lunar time. Rovers will navigate by them, habitats will schedule by them, communication relays will depend on them, and when those clocks start ticking, the drift that Moontime Now tracks today, that abstract accumulation of microseconds, will become operational reality. Every 56 microseconds per day will matter. Every correction will reference the same epoch, J2000.0, that the site uses right now. We are living in the transition, the moment between looking at the moon and living on it, between wondering what time it is up there and knowing, precisely, relativistically, to the microsecond. moontimenow.com, the moon's time, right now.